Yay. And I timed the talk, and it was 42 minutes, so I think I'm in perfect shape. My name is Brian Duggan, and I'm going to talk about Perl 6 on Jupyter. I want to do a little poll first. How many people have heard of Jupyter, Jupyter Notebooks, or IPython notebooks, or similar things? Okay, about 50-50. Good. And how many people use Perl 6, or know something about it? Or okay, also okay, good. Okay, so my name is Brian Duggan. I'm here from the US, from Philadelphia. I work for a company called PromptWorks. We're a consulting company. We do projects in a variety of languages: Perl, Python, Ruby, JavaScript, Elixir, Go. We're a polyglot organization. This is an outline of my talk. So I'm going to start off with a little introduction about Jupyter, the Jupyter system, notebooks, and the console client, some of the architecture for Jupyter, what's it all about. And then I'm going to talk about some of the specifics of the Perl 6 kernel that I've been working on, including auto-completion. And then I'll get into, after talking about the console, I'll talk about notebooks. I'll talk about magics, which are they're sort of like macros in a way. They kind of transform the input or the output of different notebook cells. And then I'll go into some more clever things like comms, which are ways of doing asynchronous communication between the notebook and the server. And then finally, I'll go through a sort of a fancier notebook example and show you how to put some of these different features together. But first, if you have a laptop, you can play with Jupyter Notebooks while I'm giving this talk. If you are looking at your laptop anyway and want something to do, you can go to this URL, which is also linked in the schedule. This is the Git repository for the kernel, github/bduggan/p6-jupyter-kernel. And you'll see a button there that says Launch Binder. That links to a site called mybinder.org. And when you click that, it'll automatically spawn your very own Docker container that's running Perl 6 and interacting with a web Jupyter Notebook. Okay, so a little bit about Jupyter. So Jupyter started off as it was called IPython at first. And the goal of the project was sort of to take people who were familiar with using a REPL, a read, eval, print, loop interface, and just make it a little bit better. So some of the improvements that were made were, for instance, making it, they called them rich interactive shells. So instead of only sending text and getting back text in your REPL, you could also get back graphics. So you could generate graphs, visualizations of data. You could separate the server from the client so that you could do more complex calculations. IPython, when it became Jupyter, part of the reason it was called Jupyter was because they were focusing on three main languages: Julia, R, and Python. And in fact, just a couple of hours ago, I went down to the data science track, and there was a talk about Julia, and they were using a Jupyter Notebook. So it's pretty popular. There are about 500,000 of them on GitHub, as a statistic I read somewhere. They support about 40 languages, and now Perl 6 too, obviously. And they're very popular in the scientific community. So a popular use case for a Jupyter Notebook is to go through a sequence of steps in a computation and to sort of show the results of each one. And after you do this sort of session of interacting, showing the input and the output, you can hand it to somebody else who can then repeat the process easily. So it's a way of sort of sharing results and sharing algorithms between people. Some academic journals have even had some integration with notebooks. Nature did something with them on their website at one point. So yeah. Okay, so let's talk a little bit about the architecture. Okay, so your typical read, eval, print loop looks like this. You read something, and then like 1 + 1, you evaluate it, you get 2, and then you print it. So you print the string 2. Usually this happens all in one single server. You have a single program, single process. Come on in. And it's sort of a simple interface to to any program. So the Jupyter architecture basically takes the R and the P and the E and splits them up. So the read and the print go over here on the client side, and the eval goes over here on the server side. Actually, even further over here, not just so there's a server in the middle, and then over here on the left is something that they call the kernel. So the client can be either a web page, which is using WebSockets and HTTP, or it can be a console client where it's using curses or terminal stuff. There's, I think, a Qt client also that has another sort of interface. And then the kernel is sort of independent. It can be written in whatever language, and it communicates with the server. You can also have multiple clients on the front end and multiple kernels on the back end, and the server in the middle does the brokering between the two. So every time you open a new notebook, it gets its own dedicated kernel. So you can have several sessions running at the same time with the server in the middle, making sure that everybody gets the right messages. So here's another diagram. This is from the documentation, the Jupyter documentation. So in the web use case, you have this notebook server in the middle that's sending stuff to the browser with HTTP and WebSockets. It uses 0MQ to communicate with the kernel. I'm not going to talk about that protocol, but it's kind of messy. And then this server also keeps track of the session. So it writes to this notebook file. And the notebook file is basically just a bunch of JSON that says, like, here's the input, here's the output, here's maybe something about the type of the output, and a few other things. But it's a simple JSON file. It ends with the IPYNB for Python notebook suffix. And if you take one of these JSON files that ends in that suffix and you put it on GitHub, it'll magically be rendered as a nice visual sort of representation of the session. So just the same way that GitHub renders Markdown and these other things, it also renders IPYNB notebook files. So it's a handy way to sort of share, this is what I typed and this is what I got. So what happened when you typed that, kind of a thing. Another note, some other assumptions, some other aspects of the architecture. There's not really security. It's not really about security. You're running your own code. So even though there's a client-server thing, if you want to crash everything, you can. If you want to use up all your resources, there's no sense of your typical client-server thing. It's like, you assume the client is dangerous. But in this sense, you're controlling the server. So the security has to happen outside of the system. Yeah, that's it. And in addition to GitHub, there are other places that render the notebook files, like nbviewer.jupyter.org. OK, so we'll take a look at the console client first. So once you install everything, if you type Jupyter-console and say --kernel equals Perl 6, this will launch a console client. I like to alias that to iPerl6. And you get this nice interactive shell. And you'll be greeted with this prompt. It says in brackets 1. And if you type something in there, then you'll get out brackets 1. So if I type in the string hello world, then the result of that expression becomes out brackets 1, which is the string hello world. And you can do the same thing with in2, and you get out2, and so on. There's some special tricks you can do. So for instance, the underscore, which came from, believe it or not, Python uses underscore, just like we do in this situation. Underscore refers to the result of the last output. So in in2, it's a little dark here, but it says underscore.flip. And what that means is take the last output and call the flip method on that string, which reverses the string. And then you can also refer to the variables. So then those become immutable variables inside Perl 6. So there's a out brackets 1, and if you just type that says out brackets 1 dot UC, that's calling the uppercase method on the string hello world, which gives you hello world in all caps. It's a little bit dark there, but I don't know if you can see there's an in 1, out 1, in 2, out 2, in 3, but there's no out 3. Does anybody see why there's no out 3? It's a little dark, but the reason is because in 3 it actually says say hello world, or it says say out sub 1. So it's sending stuff to standard out. So basically, in addition to having cells that are the last expression, you can send things to standard out, and those things will appear in between the cells, but they won't be put into the in and the out variables. So auto-completion just sort of works the way you would expect it to for the basics. So if you declare a couple of lexical variables here, and then you start typing $something dash, and you hit tab, you get a list of the different lexical variables. In Perl 6, the way to do that programmatically is to call the .keys method on lexical : and that's the sort of the local symbol table. So that's how it works behind the scenes. You can also autocomplete methods. So if you have a variable or an object or pretty much anything, and you type dot, then you're about to make a method call. And so then if you press tab, it'll look for the methods. Now this gives it gets a little interesting in Perl 6 because there's a very rich type hierarchy. So this is a picture of the type hierarchy. Maybe I can zoom in here. Let's see. That didn't work. Control. There we go. So this is the type hierarchy. So int is in the middle here, and you can sort of see that int inherits from real and inherits from numeric. And int also inherits from something called cool, which is something that could be an integer or could be a string, which inherits from any, which inherits from the generic class. And so there are actually a lot of methods on integers. And so if you just press tab, you'll see a huge number of methods, most of which you're probably not interested in. So by default, if you just do a dot and you press tab, you only get the local methods from the int class. But then if you start typing something, then it searches the whole type hierarchy to try to find out what you're looking for. And that distinction is made. So if we'll do a little example here. We have 12. We do tab. We get a lot of stuff. And the way it finds out what the methods are is it calls .methods on number 12. So these are all the methods just for the int class. But then when it wants to find all of them, it sends the all flag like that. And then this goes on and on and on. And there's a lot of stuff in there that's probably not what you're looking for. You probably don't want to uppercase your integer, but it's there in case you are doing something else that's not in the immediate class. There are some other cute shortcuts for auto-completion. You may or may not have heard that there's some cool Unicode stuff you can do with Perl 6. One of my favorite things is the set operators. So if you have two sets and you want to find the intersection or the union, you can use the Unicode union or intersection operator. If you don't like typing Unicode, there are always ASCII variants of the operators. So for instance, usually it's open parentheses, vertical bar, close parentheses. It's kind of like an OR for sets. That's how you do union. So if you start typing open parentheses and you press tab, you can see all the Unicode set operators. So it's very handy for typing those in. Similarly, subscripts in Unicode behave like exponents. So if you don't want to do star star, you can type star star and hit tab, and then it'll be easier to enter Unicode exponents. The atomic operations, so these are useful. One of the cool features about Perl 6 is the threading capability. So it's very easy to start multiple threads that are then using the same variables. So if you're not careful, you can have race conditions. in order to help you with that, Perl 6 provides a number of atomic operations, atomic dash something. And if you don't want to type all of that out, you can use the Unicode atom symbol, which is a shortcut for some of the atomic operations. I'll show you an example of that later. OK, so let's look at the basics of a notebook. So if you're not using one of the online versions that provides you with your own Docker container, if you've installed it locally, you type Jupyter Notebook, and it'll pop open a web page, and it'll start a server. And then you can go to File, New Notebook, Perl 6 to start a notebook. You'll have cells like this. As you can see already, this presentation is actually a notebook. So you get your ins and outs on the left. After you type something, you see the result of the execution underneath it. Control-Enter will execute a cell. So here we can do 2 to the 27 minus 1. And then you can edit the cell and rerun it if you want to. So we can go back and we can say 2, and then use auto-completion to say 1, 27 minus 1. So it looks a little nicer. And then, for instance, does anybody recognize this number or know what the answer is if I ask whether or not this is a prime number? Any guesses? Yes, everybody knows. OK, so correct. It is a prime number. This is a Mersenne prime, one of the ones that he got correct. There were a few that he got incorrect, but this one is prime. I tried. There was just in January, the largest known prime number was calculated. It's 2 to the 7 million something. I tried it in the notebook, and it did not calculate. OK, so these are the important things. Control-Enter, Alt-Enter will give you a new one underneath. If you see a little star, that means it's busy. And then, like for reproducibility, there's an option in the menu to just clear all the inputs and sort of take it from the top and rerun everything. OK, so output cells and standard out can have MIME types. So let's say we have a little expression here that's just in SVG. So this is just the Q is just a Perl 6 quoting construct. This says, here's a here doc. And this is sort of a very tiny SVG. If we run this, we're going to get a red circle. So it says, oh, it's an SVG. I'll render it as an SVG. What else? So magics are ways of telling the kernel what to do. Like I said, they're sort of like macros, but they can do a little more. They're a little more powerful. So just like you can have SVGs, if you want to explicitly say the output here is HTML, you can do that too. So if you start a cell with %%, or if you want it to be a comment, you can have it start with number %. The first line is interpreted as a magic, and there's sort of a list of them you can see in the documentation. So %HTML says, I'm generating HTML. So this string here, instead of being escaped, will just get rendered in the browser. OK, so this is so you get your bold and your italics. You can also generate LaTeX. So this was, as you can imagine, a feature that was very useful for scientists sharing results with a lot of equations. The notebooks themselves support LaTeX cells, but you can also produce LaTeX output. So in this example, I'm producing a LaTeX that's a fraction with 1 in the numerator and 2 in the denominator, and I'm wrapping it in a LaTeX equation block, and that gives me a half. This one, any LaTeX people can tell what this is going to be before I run it. Quadratic equation, yes. OK, so you can get as complicated as you need to with your LaTeX. OK, so some other cute magics. We have bash and run. So if you start the cell with bash, that means actually I'm not writing Perl 6. I'm writing bash. So here's a little bash script that echoes a bunch of strings into another file. So remember, there's no security. You control the file system. You can do whatever you want, even though it's a client-server situation. So we're going to make a file here that has 3 lines, and then we're going to cat the file. So we'll run this, and here's the file we just created. And then run will take a file that's somewhere on the disk and run it. And what's kind of interesting about this is that it doesn't just run it in a sub-process in its own lexical scope or in another process. It runs it within the context of the current cell. So that means any variables that are declared inside that file are now accessible to you inside the notebook. So I'm going to say run calc.p6, which is the file we just created, and then I'll be able to print out $distance, which was declared inside an external file. So that's something it's a little hard to do just in Perl 6 alone. But you could do it in the Jupyter Notebook. JavaScript is also possible. So there's a JavaScript magic. If you say %% JavaScript, it means, OK, this is not Perl 6, and it's not Bash. This is just JavaScript. And you can just do whatever you want on the client. So in this example, I'm saying element.append, and jQuery is available. So it's saying add a div to this element and put some text in it that says hello world. OK, so let's run this. With JavaScript, you can also use external libraries. It gets a little bit tricky depending on the way the import is done with JavaScript, but one way to do it is with require.js. So in this example, I'm loading a library called chart.js. I put in comments the CDN location, but I'm serving it locally since I didn't trust the wireless situation. So I'm going to run this, and this loads chart.js into the browser. And so what can you do with a JavaScript graphing library? Well, let's make a data structure in Perl 6 and send it to the JavaScript graphing library. OK, so here's a little data structure that I'm making in Perl 6. This is just a nested hash. We've got a type called bar, sending an argument type bar, saying we're making a bar graph. I've got some labels going from happy face to smirky face. So this is just a range of all the Unicode characters in between those two. And then I've got a few pieces of data underneath that are going to be on the graph that I'm generating. And if we run this, we get this data structure. OK, so remember, it's just evaluating the Perl in this case. And then I can generate some HTML and take the data structure that I just created and insert it into the HTML. So I use the HTML magic, and I use JSON fast. And then I just write a little bit of, I write a canvas, and then I have this little, there's a little interpolation here where I kind of like turn it into JSON one place and then turn it back in the HTML. And then we run it, and we get a nice graph. So, you know, and you can, so it's sort of an interactive graph. So already you have some nice sort of interactive, sort of minimal interactive data visualization just by generating Perl 6 data structures and using JavaScript graphing libraries. And you can do this kind of thing with whatever, you know, 3JS for 3D visualizations, any client-side utilities will work fine. OK, so let's talk about something a little bit trickier, and that is something that they call comms in the Jupyter world. And I'll just use the definition from their documentation. So the COM API is a symmetric, asynchronous, fire and forget style messaging API. It allows the programmer to send JSONable blobs between the front end and the back end. OK, so the Jupyter kernel supports the COM API. And I'm going to show a few examples of how this works and why it might be useful. Okay, so the way it works is you use a variable called $Jupyter, and you register a com. And what that means is you say, take this name and associate it with this function. And the function then is going to get two channels. So in Perl 6, a channel is a built-in data type. A channel is a thread-safe queue for stuff that's going in one direction or another. So I'm registering a com here called counter, and the arrow there is saying here are the parameters for the function. It's getting a channel which is called $out, and then within the function I'm creating an event loop that is essentially saying every 1 second send a new number to the $out channel. Okay, with me so far? So the react whenever supply.interval1 means supply.interval1 is make a new supply where every 1 second you send me the next number. And then the whenever says associate this callback with it. And then react says make a new event loop. And then we call done when I reaches 5. So if we run this code, we are creating a com. And then on the front end, we use the Jupyter com API and say, give me a new com that is registered as counter on the back end. And then make a new div element and associate with this com a callback on the front end that says every time you receive a message, put it into the div element. Okay. Is that straightforward enough? Sort of? Okay, that's what we're going to get. 1, 2, 3, 4, 5. Very exciting. Yes. Okay. And I have another example with comms to show you the two-way communication. And this example, so bear with me for a second. We have an integer, and we're going to start it at 0. Now, every second, we are going to send out the sum of that integer and the next number that comes back. We're also going to start a separate event loop that is going to receive messages. Whenever we get a message, we're going to add that. We're going to assign that to our integer. So we're going to send numbers. We're going to start counting, like 0, 1, 2. But then if somebody says, here's 100, then we're going to say, OK, 103, 104, 105, like that. So we have two event loops. They're both using the same variable, $num. Therefore, to avoid race conditions, we declare it as an atomic int. And when we assign to it, we use atomic assign. So this code would work fine if we didn't do that. But there would be the possibility of race conditions. OK. So let's run this, which registers this com. And then on the client side, we're going to get one of these coms. And we're going to send it the number 10, then the number 20, then the number 30, then the number 40. So we're going to keep on increasing the number that's being added to. So what we're expecting to get back is 0, and then we're going to send 10. Then it's going to say, oh, I'm not going to send you 1. I'm going to send you 10 plus 1, or 11. And then we're going to send 20, and it's going to send, OK, I'll send you 20 plus 2, which is 22. So this is an example of the kind of thing you can do with two-way communication. And you can sort of start with this as an example for yourself if you want to build on it and make something that does something more important. Okay, so now I'm going to finish with a slightly fancier notebook to sort of illustrate the kind of thing you can do with a visualization and with messages coming from the server to the client. Okay, so we're going to use the D3 visualization library to visualize the Fibonacci sequence. We're going to make a sequence of, we're going to have every second we're going to send a new number in the sequence, and we're going to send some other stuff too. Okay, so we all know the Fibonacci sequence, 1, 1, 2, 3, 5. The ratio of successive terms, 1 to 1, 2 to 1. Does everybody know this, that it approaches the golden mean, 1 plus the square root of 5 over 2? Okay, this was credited to Kepler, I learned. And so what we want to do is we're going to visualize this by constructing a golden rectangle, which is going to have this ratio. So this is how we're going to do it. We start with a square in the middle that's 1 by 1. Then we put a square on top of that one that's also 1 by 1. Then we put a square next to it that's 2 by 2. Then we go down, we make one that's 3 by 3. Then we go over, we make one that's 5 by 5. And so the Fibonacci numbers are the lengths of the sides of the rectangles, 1, 2, 3, 5. And we're rotating, we're going this way, this way, this way, this way. So we basically have a sequence of these directions which are vectors. So we're going the direction 1, 1, and then 1, let's see, negative 1 in the x direction, 1 in the y direction. So we have these different directions. And then by multiplying the Fibonacci numbers by the directions, we're going to get a vector that is the diagonal. And the goal here is that we want to compute these coordinates for the different corners of the rectangles. Okay? So the diagonals then are the first list times the second list, where times means multiply a scalar by a vector. Okay, so for instance, 5 times 1, 1 is 5, 5. Okay, so these are our different diagonals. And then the corners are going to be the sums of the diagonals so far. Okay, so we start with 0, then we add 1, then we add the first 2 to get here, then we add the first 3 to get here, right? And then we add the 4 to get to the fourth. Does that make sense? Yeah. Okay. So this is going to be our algorithm now. So now we are going to do 4 lines of Perl 6, one for each of these lines, to generate these 4 infinite sequences, and then we're going to send them out to the client one at a time and see if we can make a visualization. Okay. So the first one is easy. This is one of the well-known ways of sort of showing off some of the functionality of Perl 6, where you can use the sequence operator, ... to generate an infinite sequence. So you say 1, 1, and then star plus star means, so whenever you see a star is called whatever star. And when star is used in an expression, it turns the expression into a subroutine, and then it becomes an argument to the subroutine. And if you use it twice, then the second one becomes the second argument to the subroutine. So star plus star says, make me a routine that takes 2 arguments and returns the sum of the 2 arguments. So by saying 1, 1, star plus star, this tells Perl 6 how to generate the next element of the sequence. So we say 1, 1, star plus star, ... infinity, and the infinity Unicode symbol works. So now we're going to evaluate at Fibonacci up to 20 to show the first 20 numbers. So let's run this one. Okay. All right, so far so good. Okay, so for the next one, the direction. So the directions are pretty easy. This is just these 4 directions repeated an infinite number of times. So we just write the lists, 1, 1, minus 1, 1. We have to put the vertical bar at the beginning, which sort of flattens it. And then XX is the list repetition operator. So this makes an infinite list of these 4 numbers. And so let's print out the first 5 of those to see how that looks. Okay. So the diagonals, now this is going to get a little tricky here. So you remember how I said we're multiplying a number by a vector? So the way to multiply a number by a vector is to use the multiplication operator surrounded with a pair of angle brackets. A pair of angle brackets makes an ordinary operator into a hyperoperator. And it says, instead of just multiplying these numbers together, multiply corresponding numbers together. So 1 hyper times, or 5 hyper times 1 comma 1 is 5 comma 5. So we want to combine these 2 arrays, and the way we're combining them, so we combine them using the zip operator. Zip says combine corresponding elements of the array, but zip takes an argument, which is the operator. So the argument to the zip operator is the multiplication hyperoperator. I think I said that right. And so we're going to say directions zipped with the multiplication hyperoperator over the Fibonacci numbers. And this will give us 1, 1, sort of scaled. So, okay, so far so good. And then for the corners, does anybody know what operator would be useful for the corners? Okay, so for the corners, what we want to do is we want to find the sum so far. Okay, the sum of everything so far can be done using the triangular reduce operator. Okay, so you all know the reduce operator, right? Reduce means take an operator and just put it in between all the elements of the list, right? Reduce says it's like take take the first thing off, use the reduce operator, and then you get something else. Then take whatever that is, use the reduce operator, and do it with the next thing. So triangular reduce says, okay, it's just like reduce, except all those little steps you did along the way, hold on to those. Save those, and that's why it's a triangle, because you sort of generate one, and then say you're generating more and more each time. The way I like to think of a reduce operator is if you do a triangular reduce operator is that if you do a triangular reduce over addition, then from a math perspective, you're turning a sequence into a series. So the 2 words sequence and series are sometimes used to refer to just a sequence of values or a sequence of partial sums. Okay, so we are using triangular reduce, but it's not just addition because they're vectors, right? So it's hyperaddition. So to make the corners, we have reduce, which is the square brackets, triangular reduce, which is the square brackets over hyperaddition, and then we put 0, 0 on at the end. Okay, and if we look at the first 5 corners, that looks like that. And oh, by the way, we're also going to need the rotations, 0, 90, 180. You'll see why in the end. So we're just going to make this list here. So we have 5 infinite sequences. And now let's compute the ratios, because we want to approximate the ratios. So you can take every pair of things using rotor. If you want 2 and then go back 1, that's also a rotor. So this is like take 2 steps forward and 1 step backward and give me a bunch of pairs. So that kind of looks like this. And then we're just going to use regular old map to divide the 2 things one after the other, turning it into a fat rat to make it arbitrary precision. Running a little low on time, but this notebook will be available. And we also want to look at our accuracy. So doing a little algebra, we can see that 2r minus 1 squared minus 5 should be approximately 0. So we're going to use this number however close we are to 0, that's how good our accuracy is so far in the Fibonacci sequence, in the ratio. Okay, so we'll take the ratios and convert them into this form to get an idea of the accuracy. And then we need to make a bunch of messages to send to the client. Okay, so here we have another little operator thing happen. I didn't think of this, but then I was on the Perl 6 users mailing list, and Larry mentioned this just by chance the other day, and I thought, I have a way to use that. And that is a reduction using zip and comma. So we have a bunch of arrays, and essentially we want to take the first element of all of them, the second element of all of them, the third element of all of them. And so essentially we're zipping them together with comma one at a time to sort of make a bunch of tuples. But since we have zip comma in between all of our arrays, we can use reduce to simplify that. And so then we're mapping that to a little hash. Notice some of these things we're stringifying because it's arbitrary precision. Nude stands for numerator denominator, so we're going to get those things. And we also stringify the accuracy. Okay, and so now we set up our COM on the back end. And on the client side, we bring in D3. And then we have some JavaScript, which I will not go through, which I've defined for adding a square and zooming out a little bit. Finally, we create a COM on the front end, and every time we get a new message, we add the square to our drawing, we zoom out a little bit, and we show the ratio that we got from the server. So let's see what happens here. Okay. So here we get our ratios. We're drawing, using the rotations, we're drawing a new rectangle, and the ratio of the width to the height is getting closer and closer to the golden ratio every time for every square that we add. And you can see the accuracy, so there's no rounding here, right? This is arbitrary precision. So you can sort of see the accuracy on the bottom. You can see the exact ratio as it approaches the golden mean. So in conclusion, Perl 6 has a lot of cool features that work well with Jupyter. The previous example, so I sort of slowed it down a little, but in general, you could use it for something that takes a while computationally, that just sends back data as it's able to make the computations. The Unicode support in the kernel is helpful. Other things like infinite sequences and rational arithmetic can be cool for doing analyses. There's still a lot of open questions. The one on the bottom especially is interesting. You know, what do we want in the native Perl 6 REPL? How rich of a REPL should it be? Or how minimal should it be? That's it. Thank you all. Thanks to the people that helped me with this presentation. And if you want to run this talk, there's a Git repository. I'll put this link into the FOSDEM program, but you can actually just spin it up and just go through it yourself and change it and break it and do whatever you want. So thank you. Maybe I think I'm out of time for a question. Okay. Okay. Question? Any question or anything? Yes.
I actually contemplated using your software for a potential upcoming cost run in Python. I was wondering how similar it's going to Jupyter and Perl 6 is to, say,
How did you say? How difficult is it?
how close is it to the result process for the native Python?
How close is it to a native Python compiler? So there's still Python running in the middle doing the server. So it's basically the Perl 6 is doing the 0MQ communication to the server. And so it's implementing the same protocol.